Okay, so in the world of product design, you run into this huge challenge all the time. You have one perfect, unified concept, but you have to actually build it from a whole bunch of separate parts. Today, we're going to look at the amazing tool that bridges that gap, turning that one master idea into many real-world pieces.
All right, let's just dive right in by talking about a problem that really every single digital designer has to deal with.
So, imagine this. You've poured weeks, maybe months, into designing the perfect product. Let's say it's a new car shifter handle. It looks amazing. It's this single, beautiful, cohesive 3D model. So, now what? How do you take that one piece of art and efficiently break it down into all the individual components you need for manufacturing while making sure they all still know how to fit together perfectly? Yeah, that's the real trick, isn't it? Getting from that one master file to a whole collection of individual parts that are ready to go into production. You've got to somehow carve out a top insert from the design, a shifter body from the same design, and you have to do it in a way that guarantees they're going to fit together flawlessly every single time. And that, my friends, is where a really powerful tool comes into play. It was designed specifically for this top-down way of thinking, where the big, overall design idea dictates what all the little individual components look like. It's called the Wave Geometry Linker. Now, don't think of this as just copying and pasting. That's kind of dumb and static. The Wave Linker creates a live, intelligent, associative link between your parts. It lets you borrow the shape from your master model and use that shape to create a brand new, separate part. And the workflow is actually pretty straightforward. You're not remodeling anything from scratch. You just take your master design, create new empty part files, and then use the linker to sort of deal out the correct geometry to each new file. And just like that, you're building a fully linked assembly as you go. Okay, but here's where it gets really interesting. The power of this tool is all about how you control that link. And it really all comes down to two key settings that give you an incredible amount of precision over how all these parts are going to interact with each other. So your first big choice is associativity. Basically, do you want a live link? If you say yes and you choose associative, any change you make to the master model will automatically cascade down and update the part you borrowed it into. If you say no, well, you just get a static copy. It's totally independent from that point on. But this next setting is the real game changer. It's called fixed at current timestamp. This is where the magic happens. Instead of a live feed that's always on, you're taking a photograph. The link becomes a perfect snapshot, totally frozen at the exact moment in time that you created it. So just think about the kind of control this gives you, right? Associative is the if the parts are linked at all. But fixed at timestamp is the when. When does that link stop paying attention to new changes? This is how you lock in a design version and protect it from anything that happens later. Okay, enough theory. Let's actually see how this works in practice. We're going to go back to that shifter handle master model and build a real assembly right now. So first, we'll create a new, totally empty component file for that little top emblem. Then we use the wave linker, we reach into our master model, and we just pull in the geometry for that specific piece. Done. And then we just rinse and repeat. We do the exact same thing for the main shifter body, borrowing its shape from that same master file. And just like that, we have two completely separate components, but they're both intelligently linked back to our original design. And right here, this is the magic. This is the whole point. We can now add details we need for manufacturing, like maybe we add a new decorative ring directly to the shifter body part, and it doesn't affect the top insert at all. But because they're both linked to the same master, they stay perfectly aligned in the final assembly. It's brilliant. Now look, a tool this powerful, well, it comes with some risks. With this much power comes some pretty serious pitfalls that you absolutely need to be aware of. All right, let's really put that fixed at current timestamp feature to the test, shall we? We're going to go all the way back to our original master file, and we're going to add a brand new feature. Let's say we drill a hole in the emblem, long after we already borrowed all that geometry. So, here's the million-dollar question. Does that new hole we just made suddenly appear in the final top insert component that we already created and modified? And the answer is a big, fat no. It doesn't show up. Why? Because our link was that snapshot in time. It completely ignores any changes made after it was created. This protects our finished component from later design tweaks that have nothing to do with it. And that immense power is exactly why you'll hear experts in the field give a pretty serious warning. They'll tell you that while it's fantastic, you can get into some really big trouble with it if you're not super careful. So what's the big danger? It really boils down to one word: complexity. It's just too easy to overuse this and create a tangled web of links that becomes impossible to manage. And imagine you're on a team. If one person changes a master file and doesn't tell anyone, the whole assembly can just break in all these weird, unexpected ways. So, what's the bottom line here? The Wave Geometry Linker is absolutely a transformative tool for assembly design. It gives you incredible control, but it's got to be used with some real planning and discipline. It really shows you the power of creating these intelligent links between digital objects, which, it leaves us with one final thought. What happens when we can create these same kinds of intelligent, updatable links between our physical objects out in the real world?